Greetings and welcome back to video number 2 where we're talking quadrilaterals, and we spent our first video classifying those quadrilaterals, and now we're going to spend this second one finding an angle measure within a quadrilateral. You've already taken some notes from page 295. You learned very easy that all you have to do is add the 4 angles and know that the sum of those 4 angles is equal to 360 degrees. So if you write out an equation, it's easy to solve. Pretty straightforward stuff. So ladies and gentlemen, let's do a quick reminder of the formula that I showed you in our triangle video notes, where we took the number of, 180, and we multiplied it, 180, and we multiplied it by the number of sides minus 2. And so in this case, we have a quadrilateral which has 4 sides. And if we subtract 2, we get 180 times 2, which is 360 degrees. And that is the proof that a quadrilateral has 360 degrees worth of angles. And of course, just like we did with the triangle, you could take and you could cut any quadrilateral, make straight sides. If you cut these angles off, all of them, you cut all 4 of those angles off. If you put them together so that their vertex is in the center, you will find that they form a circle. Well, what's the degrees of a circle? Because if you put all 4 of those angles together, they would then form a circle, and that is also 360 degrees. So lots of ways of proving that the interior angle measure sum of a quadrilateral is 360. So let's just get busy with a couple examples and we'll be done. Finding an angle measure of a quadrilateral. So here we have a quadrilateral. As you can see, it has 4 congruent sides. Doesn't have any right angles. And the only thing I know that has 4 congruent sides with no right angles, that is a rhombus. So if you wanted to know what that was, it is a rhombus. And all we have to do then to find the missing angle measure x is to take the others, add them up. We have 124, we have 56, and we have another 124, and then we have x. And that is equal to 360 degrees. Of course, when we add these 3 angles together, by simplifying this equation, by combining like terms, that's 304 plus x is equal to 360. Subtracting 304, you would find that x is equal to 56 degrees. Now, ladies and gentlemen, that should make sense, because in a rhombus, like any other figure, if they have these congruent sides, the opposite angles are going to be equivalent. So if this one's 56, then x has to be 56 degrees. Very good. Moving on to our next one. Here we have a quadrilateral. I don't see any congruent sides. I don't see anything parallel. There is nothing there that says it's anything more than just a plain old quadrilateral. No special quadrilateral here. Adding together the sides, we have 120 plus 40 plus, remember, this angle right here that has that box in it doesn't give us a number, but we know what that means. That's a 90-degree angle. Plus x is equal again to 360. Combining our like terms, we have 250 plus x is equal to 360. And then when I subtract the 250, I find that our angle that we don't know is equal to 110 degrees. Okay? 110 degrees. That would make sense. If I look at that angle, it does look like an obtuse angle, so it is most likely 110. Makes sense. Moving right along, here we have another quadrilateral. Now, it doesn't have any marks on it, but I can visually see, I can tell, we have the adjacent sides. The adjacent sides are congruent. I can tell that this one here and this one here, these are congruent. And we won't want to get stuck with the fact that these opposite angles obviously are the same. So does that make these opposite angles the same? Well, no. You can pretty much see this one is less than 90. This one's greater than 90. We have a kite here. And so we're just going to figure it out. We've got 2 90s. Plus we have the 55. Plus our x is 360 degrees. Adding these together, simplifying the equation, 235 plus x is equal to 360. Subtracting 235, and we get that our angle x is 125 degrees. Makes sense? it is definitely an obtuse angle, 125 degrees. Moving on again, here we have what I would call a parallelogram. I see opposite sides that are equal and congruent. Maybe they're the same length, maybe not. It might be a rhombus. It might be. So let's just take a look. Definitely a parallelogram. Remember, all rhombus are parallelograms. Not all parallelograms are rhombus, but all rhombus are parallelograms. Let's just add these angles, 112 plus the 268 and plus the x. That is equal to 360. Simplifying the equation by combining all the like terms, you get 248 is equal to, plus x, plus x is equal to 360. Subtracting the 248, and x, in fact, is equal to 112 degrees. So yes, opposite angles are the same, so most likely that is a rhombus. All right, our last example before we do our quick writes. Here we have what you can recognize as a trapezoid. It has one pair of parallel opposite sides. So we just add the four angles, 125 plus 135 plus 45 plus x is 360 degrees. Notice the process is the same for every single one of these. Find the missing angle measure. I'm sure you understood exactly how to do this after our first example. However, as we do here, we give plenty of examples. So 305 plus x is 360. Subtracting the 305. And we get that x is equal to 55 degrees. Makes sense? It is less than 90, so 55 would make sense. Alrighty? And notice it has four different sides, so that means there's going to be four different angle measures. Alright, our quick write to finish off our notes tonight. Find the value of x. Please do me a favor. Again, just draw the figure. It doesn't have to be perfect. Okay, you can just make some kind of figure up. You go x here, you can put the 90-degree angle there, you put the 90-degree angle there, 115, and there you go. Label them, find the value of x. Write down any questions that you have regarding your notes on quadrilaterals. Highlight your notes, whatever it takes. Begin working on your assignment. Remember, you have 45 minutes of quality work that you need to put into your assignment. Be aggressive, use a little bit of urgency, force yourself to focus by moving along a little bit more quickly. Use your time effectively. If you put in the quality time, you will find that all math does become easier, guaranteed. Thank you so much. It's always a pleasure working with you. I'll see you tomorrow.